Hey guys, this is the video solutions to the formative on 3.1. When you're done correcting yours, you should go to Delta Math and there's a 4-problem quiz that you're going to take. If you get all 4 right, you'll move right on to working on the circuit. For each one that you get wrong, there's a video assigned with some corrective problems assigned. And so you'll need to do that in order for me to give you a score for the quiz. So ideally everyone ends up with 100% because everybody does the corrections. All right, so we are going to hop on to Formative 8.1 on our chain rule. And this is in the back of your note packet. So there's no handout for you. I have the formatives stapled in the back. So the first step is a tabular representation of the functions f of x, g of x, and their derivatives at 4 different values of x. And we're being given a third function called h. H is the product of the linear function x and an unknown f. And then added to it, the function g with 2x minus 5 inside of it. So we've got a couple rules going on. First, we need to use the product rule. So to find our derivative, we will do first d second plus second d first, the derivative of x is just 1. That takes care of the derivative of the first part of the sum, but then we need to take the derivative of this function that's inside of g. So we need to do g prime, the derivative of the outside function, times the derivative of the inside function, which is just 2. And we're being told to do that at 3. So we need to do 3 f prime of 3 plus f of 3 times 1 plus g prime of 2 times 3 minus 5, which is 1, and then times 2. So we have to go read our table for f prime of 3. F prime is right here, 3 is right here, so that'll be a 4. Plus f of 3, which is a negative 4, plus g prime of 1, which is negative 2, times 2. So it looks like we have a 12 minus 4 minus 4. Or 12 minus 4 is 8, minus 4 is 4, for an answer of A. The next one is a function with an independent variable of theta. We need to rewrite that so we can see that the outside function is the cubing function. So we will bring the 3 out front. We won't touch these guts. We'll go cosine of 8 theta. We'll drop the power down 1 times the derivative of the guts. Okay, the derivative of cosine is negative sine of its guts times the derivative of its guts, which is 8. So it looks like I end up with a negative 24 cosine squared 8 theta times sine of 8 theta once I put my two constants multiplied together out front. Number 3. Ooh, this one looks a little tricky, doesn't it? This is the natural log of a function of x. And to find its derivative, we will need to do 1 over u prime, or 1 over u du dx, or also known as u prime over u. So my denominator is the function itself. In the numerator is that function's derivative, but it's the product of two functions. So I have to do first, the derivative of e to the u is e to the u du. So that's first d second plus second. D first is just 1. So that is my u prime, would be this guy's derivative, over u, which would be over itself. I'm not seeing that over there, and that's because I can factor in e to the negative x out of the top. And then it's going to cancel with the bottom. So I've got a negative x plus 1, which is the same as 1 minus x over x for d. And last step, a little FRQ. Find the derivative of g. G is a function within a function, so to take its derivative, I'll do the outermost function first, which is a power function. So I do 3, don't touch those guts, times to the second, sorry, drop the power down 1, times the derivative of those guts, which will give me 12x. I write it out nicely, times 2x squared plus 1 quantitatively squared. Find the slope of the tangent line to the graph of g. That would be called the derivative of g at 1. So all I need to do is go put a 1 in for my x, which would be a 12 times 2 times 1 plus 1, 3 squared, which I could leave like that, I suppose, but what is that, 12 times 9, 108? That's a very steep curve. But if you think about what that function looks like just the cubic function looks like this, and that's twice x squared plus 1 cubed, so it's going to really shoot up. So that makes sense that it's got such a steep positive slope. Find the equation of a tangent line to the graph of g. We need a point, so we need 1 comma, wherever the y value is at 1. So first of all, we're just talking about the function itself. So I'm going to go put a 1 into g. 2 times 1 squared plus 1, 3 cubed, 27. I get when I put, there's my point on that curve. I'd be at the point 1 comma, 27 on the graph of g. I need now to find the equation of the tangent line, which means I now need the slope, which is the derivative there, which I already found to be 108. And now I do my point slope form. Y minus the y I know is equal to the slope there times x minus the x I know. Got a little delay in my writing, but that would be an equation for the tangent line. Determine the points at which the graph of g of x has a horizontal tangent. What that means is its derivative has to equal 0. So I'll go back to my derivative from part A, 12x times 2x squared plus 1, was it squared? Yeah. And I need to figure out where does that equal 0. And 0 either when 12x equals 0, or x equals 0, or when 2x squared plus 1 equals 0. And a number squared can't be negative, so that's not going to give me any solutions. So it says the points, my x value would be at 0. And now I need to figure out what's my y value there. So I go back to my original function, and I put a 0 in for x, back to my original function. I get 2 times 0 squared plus 1 cubed. That's going to give me a 0, 1, which actually makes sense if you think about the graph. So the graph of this is right here, basically. When I double it, because it was, what was it, 2, I can't remember what they're, it makes sense that we're going to have that slope being 0 just at that one little turning point. That's my words we move. So we're going to be done here. So after you're done checking that, you're going to head on out to Delta. You're going to take a 4-problem quiz, hoping to get all 4 right, so you can move right on to your assignment for today. But your points in my gradebook are going to come from, you're only going to get 100. You're either going to get 100 right away, or you're going to go through the correction process on there to get 100. Have a good one, guys.